Kumar Sivaratri, please mute your audio. Kumar, Kumar Sivaratri, please mute your audio. Kumar, please mute your audio. Okay, good. So discuss about the rating of the substation. So in different cases, that is square shaped and hexagonal shaped, and also n number of primary feeders, and also you have to compare the 4 feeder and 6 feeder pattern also. So after then we have discussed about the bus bar arrangements. Single bus bar with sectionalization, double bus bar with single breaker, main and transfer bus bar, 1.5 breaker bus bars. So then we go for the substation layout. So generally substation layout is nothing but a higher voltage must be stepped down into lower voltages, and then that lower voltage may be given to the consumer premises. Generally the incoming line of the substation is nothing but 33 kV line, and that may be connected to the bus bar through the go switch and lighting arrestor. And from this bus bar, so number of feeders will be taken. So first feeder, second feeder. So in first feeder, 33 kV line go switch means isolators. Then 33 by 11 kV transformer, step down transformer, and CB, IL circuit breaker 1. Again 11 kV by 230 volts or 11 kV by 440 volts bus bar, isolator, circuit breaker, step down transformer, again isolators, reactor, isolator, circuit breaker. So here 33 by 11 kV by 230 volts transformer also available in this situation only. So like that, generally what is substation is nothing but substation is a combination of operators, otherwise assembly of operators installed to perform voltage transformation and converting operations, switching operations, power factor conversion operations. All these done in substation layout only. That means to reduce the voltage, to transfer the power, so to convert the some cases to convert AC to DC, like that all possible operations, all possible switching operations may be done at substation only. Now we have to discuss about so each and every equipment in substation, that is nothing but substation layout. So that is the diagram. So the main equipments of substation are first power transformer, that is 33 by 11 kV transformer, then circuit breakers, protective relays, bus bars, lighting arresters, instrument transformers, insulators, isolators, control room, indicating and meter equipment, current limiting reactors, shunt reactors, series reactors, shunt capacitors, coupling capacitor, station, batteries, ground wiring or grounding system. So other auxiliary equipments or other operators. Now going to the first of all, we have discuss about the first to discuss about the bus bars. Generally, already last class we discussed about what is bus bar and what are the different types of different arrangements of bus bars, right? Bus bar is a conductor, or these are heavy duty conductors generally, which may carry the complete load current, which may carry the complete load current according to the capacity of the substation. So the substation is small substation or big substation. that is 66 by 33 kV or 33 kV by 11 kV. So depending upon the capacity of the substation, so the bus bars are carry the entire load current, right? And also the fault current for few seconds, these are either copper or aluminum bars with rectangular cross section bars. So these are made up of copper or aluminum or ACSR conductors with rectangular cross section bars, and these are operated constant voltage in incoming and outgoing lines of a substation. Bus bars is nothing but, so they will maintain constant voltage. The most commonly used bus bars already discussed, right? Single bus bar with sectionalization, main and transfer bus bar, all these, right? Bus bar is nothing but it is a conductor, otherwise heavy duty conductor, which can carry the entire load current according to the capacity of the substation, right? And incoming lanes, outgoing lanes, you can write the bus bars, and then what are the different arrangements? Just definition, just every part we have to write 2 or 3 lines, enough. What is bus bar definition? What is the incoming line of bus bar? What is the outgoing line of bus bar? How will you maintain the voltage? Voltage is constant throughout the bus bar. And what are the different types of bus bars? Enough. Next, insulators. We know that insulators are generally insulators may support the bus bars. That means the insulators are fixed and isolate the bus bar system only. The most commonly used material for insulator is, all are well known, that is porcelain, right? Porcelain is used for the insulators, and we know that so many types of insulators are there: pin type insulator, suspension type insulator, strain type insulator, post insulators. Generally, pin type insulators are used less than 11 kV. That is rural areas where we mainly utilize pin type insulators. Suspension insulators are most used insulator is suspension insulators, and this is used for greater than 11 33 kV. So each disc in each insulator or each disc in suspension type insulators are rated as 11 kV. Every disc has 11 kV, right? And mostly used insulators also suspension type insulators, and strain insulators where the junctions are comes to the picture. Otherwise, railway crossings or road crossings, at that time we are utilizing strain type of insulators. And coming to the post insulators, the post insulators, these are the main. The post insulators are mainly utilized in substation bus bars. Substation bus bars we are utilizing post insulators, right? This insulator, generally insulator is nothing but it is not carrying the current, right? And it is connected between the phase and earth. ఇంకా రాయొచ్చు, చాలా రాయొచ్చు, బట్ అంత అవసరం లేదు. జస్ట్ వాట్ ఈజ్ ఇన్సులేటర్, what are the different types of insulators, and substation which type of insulator is used. Enough. Next, isolators. Generally, isolator is nothing but it is a just normal switch, on and off switch. Otherwise, you can call it as disconnecting switch. An isolator, or it may be a disconnecting switch, is used to open the circuit. How can why we have to open the switch is nothing but because of maintenance or repair. You have to repair the device. The isolator may be used to open the circuit. That's why isolator, or we can call it as a disconnecting switch. There are generally 2 types of isolators are there: single pole isolator, 3 pole isolators. Single pole isolators are 3 pole isolators. In the diagram The isolator is single pole isolator. Why? Because suppose the substation may be divided into sections, different sections. So each section can be disconnected from another through the isolator, disconnecting switch for maintenance. Suppose we are having two sections or three sections in the substation. From third section having some fault occurred in the third section. So at that time, we may disconnect the third section with the help of isolator and then may isolate the fault. After isolating the fault, we can again connect the third section to the substation. Next, relays and circuit breakers. Generally, relays and circuit breakers are both are related to each other. So first, circuit breaker, I can explain circuit breaker. Generally, circuit breaker is normally open and relay is normally closed. Whenever fault is occurred, relay open, circuit breaker is closed. So generally, what is circuit breaker? Circuit breaker is a protecting equipment, right? Both are protecting equipment, circuit breaker and relays. But circuit breaker is a protecting equipment which can open or close the circuit under normal as well as faulty conditions. Normal condition, it is in open condition. Whenever fault occurred, it may close the circuit, right? It can be operated manually under normal or automatically in faulty conditions. So the relay circuit used with a circuit breaker generally bulk oil or minimum oil circuit breaker MCB, otherwise bulk oil circuit breakers. Suppose voltages are less than 66 kV, we are utilizing bulk oil circuit breaker. Suppose voltage greater than 66 kV, we are utilizing minimum oil circuit breaker MCB, MOCB, minimum oil circuit breaker used for greater than 66 kV, whereas BOCB used for less than 60 kV. Now coming to the relays, these are also protecting equipment and installed for the protection of equipment against faults and overloads. Mainly overloads. So where overload occurs, where overload is occurring, load side. That's why we are utilized for protective relays to compensate that overloads. Generally, protective relay may detect the faults and initiate the operation of circuit breaker. That means generally circuit breaker is open. So please close the circuit breaker. The circuit breaker operation may decide the relay. Whenever fault occurs, relay may open the circuit and then they give the trip signal to the circuit breaker. Then circuit breaker it may be closed within a fraction of seconds and then may lose the connection from line to equipments. Therefore, equipment may be saved. Right. Next, power transformers. Mainly, power transfer is nothing but maximum step down the voltage, not step up. Step up is nothing but only one way we are using step up the voltage. That is the power switchgear in the power generating station. In generating station only we have to utilize the power transformer to step up the voltage. Remaining transmission system and distribution system, we have to always step down the voltage. At generating station only to step up the voltage, remaining all to step down the voltage. Usually for power transformers we are using natural cooling or oil cooling, right? The transformer's rating is always greater than the 10 MVA. So that may be utilized in the power transformer. Next, instrument transformers. Instrument transformers are mainly classified into two types, CT and PT. CT means current transformer, PT means potential transformers. So these two transformers are measuring current, high voltages. CT is essentially it is a step-up transformer. It step down the current to a known ratio value. The secondary of CT is always closed. This is the most important computation bit. The CT secondary is always closed. If it is CT secondary is open, so the burning of transformer, the winding of transformer may burn. So that's why always CT secondary is open, closed. Coming to the PT is usually step down transformer. Current transformer is step up transformer to measure the high currents. Whereas potential transformer is step down transformer which step down the voltage to a known ratio. So totally the transmission lines are distribution lines. Distribution lines in a substation may operate at high voltages and high currents, that is thousands of amperes. So but measuring this thousands of amperes, voltmeters are not possible and shunts also not possible. That's why so the instrument transformers, that is current transformer and potential transformers, are used. Usually the secondary side of the current transformer is 5 amperes, whereas the secondary side of voltage of potential is 110 volts. So mainly to measure high voltages, high currents, we may utilize instrument transformer, that is current transformer and potential transformer. Next, metering and indicating instruments. That means auxiliary equipments. Metering means, so in a substation, active power is measured, reactive power is measured, apparent power is measured, power factor is measured, and at instant what is the voltage, at instant what is the current, like that you can measure all the values. To measure such all the values, we may use so many instruments, voltmeters, ammeters, power factor meters, right? So that is the metering and indicating instruments. Next, power line carrier communication system and coupling capacitor wave traps, I will explain. So next, supply, AC DC supply. AC supply is used for the substation auxiliaries. Why? Because in the substation itself, a control room is there, the staff room is there. For that, we are utilizing AC supply. And DC supply is used for relay operations, right? And oil handling system. So oil handling system is nothing but it is used for purifying the oil in the transformer. Why? Because the transformer oil is always evaporated because of continuous running of transformer. Such may receives the moisture from the atmosphere. So due to that, the oil handling system is used to purify that moisture in the oil. So illumination, substation always it is a overhead, right? Overhead is nothing but always proper illuminated for the safety purpose. And compressed air system, this is used for the functioning of circuit breakers. And fire extinguisher is nothing but is there any fire accident occurs, that may utilize it for the fire extinguisher. So look at the lighting arrestor or surge arrestor. The figure of lighting arrestor or surge arrestor, 33 kV polymeric lighting arrestor, right? what is the use of lighting arrestor? Already we discussed about the lighting arrestor or surge arrestor. The your subject protective subject protection, power system protect PSP, right? Generally, all the equipments in the outdoor substation should be protected against direct lighting strokes, right? Why? Because the traveling waves are reached the station over the transmission line. That's why a shielding is necessary to protect the all equipments in the substation against lighting arrestor or direct stroke. So this is the isolating switches. Look at the figure. Isolators. So sections, section 1, section 2, section 3. So each section having one mechanical switch. So suppose third section may having fault is nothing but that section may be isolated with the help of disconnecting switch or isolator switch. After repairing, again it will be connected. These are the circuit breakers. So these are the circuit breakers. So look at the figure. So here, so the all values, that means the rating of the circuit breaker. Suppose SF6, what is the IL and what is the voltage level, what is the current level, all the rating of the circuit breaker may displayed here, and the circuit breaker is directly connected to the power nearer to the power transformer, right? So this is the power transformer, right? Look at the figure. Power transformer may utilized more than 10 MVA, 20 MVA, 50 MVA, right? This is the conservator tank and it is a cooling system, power transformer in the substation. These are the instrument transformers. So in substation itself, the instrument transformers are installed like this. So this is the normal view and this is the closed view. Instrument transformers. High current, high voltages are measured with the help of these two transformers. And look at the control room. So all the metering equipment will be, metering and indicating equipment will be displayed here. So what is active power, reactive power, apparent power, power factor. At particular failure, what is the active power, reactive power, apparent power, power factor. Similarly, remaining feeders. So what are the all the values. Control room is nothing but all metering and recording equipment are installed in the control equipment only. So already discussed about the lighting arrestor. The lighting arrestor is a device used on electrical power system to protect the insulation on the system from the against the direct lighting strokes. Generally, metal oxide varistors (MOVs) has been used for power system protection since 1970s. 1970 నుంచి మనం లైటింగ్ అరెస్టర్గా దేని యూజ్ చేస్తున్నాం అంటే మెటల్ ఆక్సైడ్ వ్యారిస్టర్ యూజ్ చేస్తున్నాం. Typical lighting arrestor also known as surge arrestor is a high voltage terminal and ground terminal. Generally, the high current may diverted to the around the protected insulation area. In most cases, earth. They may be provided grounding wire. That's why the lighting strokes may directly flowing through the ground itself. Surge diverter or lighting arrestor Look at the figure clearly. They may be directly connected to the earth or ground wire such that all the devices may protected from the direct lighting strokes. So that is the instrument transformers or capacitor voltage transformer or coupled voltage transformer. To step down extra high voltage that may provide, that is a low voltage directly. At that time we are utilizing a capacitor voltage transformer or capacitance coupled voltage transformer. Next, another one is earthing switch. Earthing switch is used to discharge the voltage on the circuit to the earth for safety purpose. Suppose high voltage will appearing because of lighting strokes, that voltage is directly connected to the earth. So that high voltage is not passing through the earthing switch. That high voltage may be discharged to the earth through the earth switch. So earth switch is connected on the frame of isolators. It is located at each corner. This is the line trap and wave trap. So line trap or wave trap is connected in series with the transmission line. So what is the main work of line trap? Line trap, how to trap the voltage or trap the current. It blocks the high frequency carrier waves and power waves. It is basically inductor of rating millihenry. It has three main components: main coil, tuning device and lighting arrestor. Isolators, these are the isolators. Already discussed about the isolator. Isolator are also called as disconnecting switch, used to make sure that electrical circuit can be completely de-energized in case of repair or in case of service or maintenance. Generally isolator is a offload device. So types of isolators are central rotating horizontal swing, central brake, vertical swing, pantograph type. These are the isolators. Now look at the figure. Current transformers. Current transformer or step down transformer used to measure the high currents. Two types of current transformers are available: protective CT, measuring CT. Circuit breakers. Generally already we discussed about the circuit breaker. Generally circuit breaker is a automatic operating electrical switch. At normal condition circuit breaker is open. At abnormal condition circuit breaker is closed. And that may be circuit breaker may be operating depending upon the relay, right? So whenever relay gives the trip signal to the circuit breaker, then circuit breaker may be closed. So relay must be open. Look at the figures. So these are the circuit breaker. All the circuit breakers and CTPTs connect to the disconnecting switches. How to isolate the arc means, so by deflection of the arc, by intensive cooling, division into parallel arcs, like that, connecting a capacitor in parallel with the contacts of these circuits. Generally circuit breakers are mainly classified as bulk oil, minimum oil, air blast, vacuum and SF6. So SF6 is the most utilized one till nowadays. These are the bus bars. Bus bars are main, it is a conductor, right? It is a conductor. And we operate constant voltage. The power transformers. Generally, step up or step down the voltages. You may utilize the power transformer where the step up all the voltage is nothing but it is generating station to step the voltage, whereas in distribution system to step down the voltage. Now shunt reactors. So what is the use of shunt reactors is nothing but to control the voltage during off load period or low load period, mainly used in EHV transmission lines. Shunt reactors are used to compensate the shunt capacitance in the transmission line. That means it may use it to improve the voltage regulation. So generally shunt reactors are unswitched. There is no switching. By using shunt reactors, you may increase the power transfer capability and also voltage regulation. Series reactors. Generally series reactors are limit the short circuit current. Mainly limit the short circuit current and also limit the current surges depending upon the load fluctuations. Where the series reactors are installed is nothing but where the fault levels are very low. Shunt capacitors. Mainly shunt capacitors are used to improve the power factor. That means to reduce the reactive power. They are used to improve the power factor. It is also used for voltage controlling during heavy lagging power factor loads. So these capacitors are located at the receiving end stations and also distribution substations. Series capacitor. Shunt capacitor is used to improve the power factor or voltage regulation, but series capacitor are used to improve the power transfer capability only. Mainly they are located at sending and receiving end of lines. Now neutral grounding. Neutral grounding equipment are mainly resistors and reactors. They are used to limit the short circuit current. Neutral grounding is point is connecting between neutral and ground. Other equipments are marshalling, kiscos, station earthing system, power cables, control cables, insulators, metering and relay and control panel, supply system. So now what is the PLCC? Not PLC, power line carrier communication. Mainly used in telecommunication system and teleprotection and also telemonitoring between the electrical substations through the power lines at high voltages such as 110 kV, 220 kV, 440 kV. The voice signal can be converted into 300 Hz to 400 Hz range. We may utilize broadband over power lines and power line networking, power line communication, carrier communication systems also. So now this is the design of 11 kV by 400 volts indoor substation. 11 kV by 400 volts. As usual, this is the bus bar. Incoming line of this bus bar is 11 kV. go switch, and underground cables, 11 kV OCB, CT secondary, minimum oil circuit breaker, this is the design of pole mounted substation. Pole mounted is nothing but, look at the figure, two poles, in between these two poles, so transformer is installed, that is H type or pole type. So these are the lighting arresters. Look at the figure, these are the lighting arresters. So lighting arresters are placed at the top place of the substation. Incoming line 400 volts, outgoing line maybe incoming line 11 kV, outgoing line is 400 volts, right? The practical pole mounted substation. In agricultural purpose, they may utilize their own transformer. That is the pole mounted transformer. Totally, substation is the heart of the electric power system or electric power distribution system. So the design should be such that it will be provide continuous, quality and reliable power supply. So with safety, then only the people may attract to consume the power, right? This is the substation layout. So we may discuss it so many parts. Just suppose in exam, just you have to write so at least 10 equipment, mainly power transformer, circuit breakers, relays, bus bars, lighting arresters, instrument transformers, insulators, isolators, control room, indicating and meter equipment. Just enough. 10 parts, 10 marks. So you have to draw the diagram neatly and then at least write 10 equipments, known equipments, well-known equipments, right? Then easy to study the question also. Now this is about substation layout, and third unit of EDS subject is also closed. So in this chapter, mainly rating of the substation, that may be a square shaped, hexagonal shaped, general case, and also 4 and 6 feeder pattern. After then, substation location or optimal place of substation location, that is the most important thing. After then, bus bar arrangements. So next, classification of substation. It may given 2 marks or 10 marks also. Last this one, layout of substation. Till now they are asking one time. I think one time. Most of the times, every question paper contain rating of the substations. That's why you have to learn the rating of the substation. After then, location of substation or optimal location of substation, bus bars. Any doubt? So in third unit there is no problems. Third and fifth units there is no problems. First, second and fourth problems will be available. There is in third and fifth units there is no problems. మనిషి ఏమైనా డౌట్స్ ఉంటే అడగండి అమ్మా.